Hi students, I am Rashmi and you are watching my channel Tricks to Crack Competitive Exams. In this video, I am going to explain Introduction to Euclid's Geometry of Class 9, solutions to each and every question of all the exercises has been solved. First, we will see some basic definitions. What are axioms or postulates? So, axioms or postulates are the assumptions. So, these are assumptions which are obvious universal truths. Axioms or postulates are the assumptions which are obvious universal truths and they are not proved. Next is theorems. What are theorems? Theorems are statements which are proved using definitions, axioms, or previously proved statements and deductive reasoning. So, this is about a theorem. We will see some Euclid's axioms. First one is things which are equal to the same things are equal to one another. So, Euclid's first axiom is things which are equal to the same things are equal to one another. Euclid's second axiom is if equals are added to equals, then the wholes are equal. If equals are added to equals, then the wholes are equal. Third axiom is if equals are subtracted from the equals, then the remainders are equal. Third axiom is if equals are subtracted from equals, then the remainders are equal. Euclid's fourth axiom is things which coincide with one another, things which coincide with one another are equal to one another. Fifth axiom is the whole is greater than the part. The whole is greater than the part. Sixth axiom is things which are double of the same things, things which are double of the same things are equal to one another. And Euclid's seventh axiom is things which are halves of the same things, things which are halves of the same things are equal to one another. Now these are Euclid's axioms. Now we'll see Euclid's postulates. So Euclid's first postulate is a straight line may be drawn from any one point to any other point. So Euclid's first postulate is a straight line may be drawn from any one point to any other point. Second postulate is a terminated line can be produced indefinitely. Euclid's third postulate is a circle can be drawn with any center and any radius. Fourth postulate is all right angles are equal to one another. Fifth postulate is if a straight line falling on two straight lines makes the interior angles on the same side of it taken together less than two right angles. Then the two straight lines if produced indefinitely, two straight lines if produced indefinitely meet on that side on which the sum of angles is less than two right angles. So Euclid's fifth postulate is little bit lengthier as compared to other postulates. Now exercise 5.1, first question, which of the following statements are true and which are false? Give reasons for your answers. First one, only one line can pass through a single point. Solution, it is false. Because from a single point, infinite number of lines can pass. Therefore, this statement is false. So consider the point as O and draw lines like this and mark these lines as R, S, P, Q. Second one, there are infinite number of lines which can pass through two distinct points. Solution, it is false. Because from two distinct points, only one straight line can pass. This is by postulate, axiom. So this is a straight line which is passing through the points P and Q. So only one line can pass through two distinct points. Third one, a terminated line can be produced indefinitely on both sides. Solution, it is true. Because it is Euclid's second postulate. It is Euclid's postulate 2. So this is a line which can be produced indefinitely on both sides. Fourth one, if two circles are equal, then their radii are equal. Solution, it is true. Because radii of congruent means equal, circles are always equal. In other words, if we superimpose the region bounded by one circle on the other circle, then they coincide. Then their centers and boundaries also coincide. Therefore, their radii will be same. Fifth one, in the figure below, if AB is equal to PQ and PQ is equal to XY, then AB is equal to XY. Solution, it is true. Given that it is given here AB is equal to PQ, take this as equation number 1, and PQ is equal to XY, take this as equation number 2. Then from equation 1 and equation 2, AB is equal to XY. This is also by axiom 1. Question number 2. Give a definition for each of the following terms. Are there other terms that need to be defined first? What are they and how might you define them? First one is parallel lines. Parallel lines means two lines in a plane are said to be parallel if they have no common point. Two lines in a plane are said to be parallel if they have no common point. Consider these two as parallel lines x and y. So in figure, x and y are said to be parallel lines because they have no common point and we write them as x parallel to y. Here the term point is undefined. Second one, perpendicular lines. Two lines in a plane are said to be perpendicular if they intersect each other at the right angles. Two lines in a plane are said to be perpendicular if they intersect each other at right angles. So consider this figure, two lines P and Q intersecting at the point O. In the figure, P and Q are perpendicular lines because they intersect each other at 90-degree angle and we write it as Q perpendicular to P. Here the term right angle is undefined. Third one, line segment. The definite length between 2 points. The definite length between 2 points is called as the line segment. This is the line segment AB. So in the figure, the length between A and B is line segment and it is represented by AB bar. Here the terms point and definite length are undefined. Fourth one, radius of a circle. The distance from the center to a point on the circle, the distance from the center to a point on the circle is called the radius of the circle. So consider this as a circle, center as O and this point as A. In the figure, OA is the radius of the circle. Here the term point and center are undefined. Fifth one, square. A square is a rectangle having same length and breadth. So square is a rectangle having same length and breadth. Consider this as a square with the points A, B, C, D. In the figure, AB, BC, CD and DA are equal. Here the term length and breadth are undefined. Question number 3. Consider two postulates given below. First one, given any two distinct points A and B, there exists a third point C which is in between A and B. Second one, there exist at least 3 points that are not on the same line. Do these postulates contain any undefined terms? Are these postulates consistent? Do they follow from Euclid's postulates? Explain. Solution. There are so many undefined terms which should be listed. They are consistent because they deal with two different situations which are as follows. First one is, if 2 points A and B are given, then there exists a third point C which is in between A and B. Second one, if 2 points A and B are given, then we can take a point C which do not lie on the line passing through the points A and B. Thus, these points do not contradict each other. These postulates do not follow Euclid's postulates. However, they follow axiom. Euclid's postulate 1 axiom states that through two distinct points there is a unique line that passes through them. Question number 4. If a point C lies between 2 points A and B such that AC is equal to BC, then prove that AC is equal to half AB. Explain by drawing the figure. Solution. Given a point C lies between 2 points, that is A and B, such that AC is equal to BC. So this is the line segment consisting of points A, C and B. AC is equal to BC, it is given on adding AC to both sides. Then we get AC plus AC is equal to BC plus AC. AC plus AC becomes 2AC is equal to BC plus AC is, so see the figure here, it is AB. This implies AC is equal to 1 by 2 AB. So this only we have to prove here, hence proved. Question number 5. In question 4, point C is called a midpoint of line segment AB. Prove that every line segment has one and only one midpoint. Solution. We have C as the midpoint of the line segment AB. If C is the midpoint of AB, then AC is equal to BC. So this is the line segment AB and C is the midpoint. There are two midpoints. So let us consider there are two midpoints C and C dash of AB. So this is the line segment AB, which is consisting of C and C dash as the midpoint. Then if C is the midpoint, then AC is equal to half AB, and if C dash is the midpoint, then AC dash is equal to half AB. This implies AC is equal to AC dash. This is by axiom 1 also. Which is possible only when C and C dash coincide. So AC is equal to AC dash, which is possible only when C and C dash coincide. So point C dash lies on C. Hence, every line segment has one and only one midpoint. Question number 6. In the given figure, if AC is equal to BD, then prove that AB is equal to CD. Solution. Given here AC is equal to BD. So take this as a equation number 1 and see the figure. From figure, it is clear that AC is equal to AB plus BC and BD is equal to BC plus CD. On putting these values in equation 1, then we get AB plus BC is equal to BC plus CD. Here BC get cancelled, remaining is AB is equal to CD. So this is by axiom 3. So it is only we have to prove, then write here, hence proved. Question number 7. Why is axiom 5 in the list of Euclid's axioms considered a universal truth? Solution. According to axiom 5, we have the whole is greater than the part. Whole is greater than the part, which is a universal truth. Let a line segment PQ is equal to 8 meters. Consider a point R in its interior such that PR is equal to 5 meters. So this is the line segment PQ, which is 8 meters, and it is a point R. PR length is 5 meter. Clearly, PR is a part of the line segment PQ. And R lies in its interior. So, PR is smaller than PQ. Hence, the whole is greater than its part. And this is true for anything in any part of the world. Exercise 5.2, first question. How would you rewrite Euclid's fifth postulate so that it would be easier to understand? For this question, you have to study the Euclid's fifth postulate and you have to rewrite it. Solution. Two distinct intersecting lines cannot be parallel to the same line. It is the Euclid's fifth postulate. It has been written in a very much easier manner. That is, two distinct intersecting lines cannot be parallel to the same line. Second question. Does Euclid's fifth postulate imply the existence of parallel lines? Explain. Solution. Yes. According to Euclid's fifth postulate, when a line X falls on two lines Y and Z, such that angle 1 plus angle 2 is less than 180 degree. Then line Y and line Z on producing further will meet in the side of angle 1 and angle 2, and whose sum is less than 180 degree. Consider the following lines X, Y and Z. This is X, Y and Z. These are angle 1 and angle 2. Thus, if angle 1 plus angle 2 is equal to 180 degree, then by Euclid's fifth postulate, the lines will not meet on the side of X. If angle 1 plus angle 2 is equal to 180 degree, then the lines will not meet on this side of X. Also, we know that sum of the interior angles on the other side of X is also 180 degree. The sum of the interior angles on the other side of X is also 180 degree. This is for a angle 1 plus angle 2 is less than 180 degree, and this figure is for angle 1 plus angle 2 is equal to 180 degree, and even angle 3 plus angle 4 is equal to 180 degree. So, they will not meet on this side of X. Hence, the lines Y and Z, see the figure, lines Y and Z never meet, and therefore they are parallel. Thank you for watching the video. Please give your valuable suggestions or opinions for further improvement.